Hi there. In this video, we're going to continue studying section 3.1, quadratic functions, and we're going to look at some applications. So applications just means we're going to be doing some word problems. So I have a few examples to work out. So the first one is we have a gardener wants to enclose a rectangular garden next to a house. The side of the house will serve as one side of the garden. If the gardener has 80 feet of fence, what is the largest possible area that can be enclosed? So let's think about this. So for word problems, always read the problem first. And it may take you, I always say, it may take you 3 times, 4 times, sometimes 10 times. It may take a while for us to get all the information. So read the problem, reread it as many times as you need to get all the information that we need out of it. So I know we want to enclose a rectangular, so we're going to be looking for keywords. So a rectangular garden next to a house. So the side of the house will serve as one side for the fencing, so that means we won't need fencing on one side. So the gardener has 80 feet of fencing to use, right? This means 80 feet of material to create the fence. What is the largest, so that's a keyword, largest possible area? So that means focus on the question. So next thing is I always say focus on the question. What are you being asked to do, or what's the task? So the question here is, what is the largest possible area that can be enclosed? So that means I'm looking for area. We're looking for the largest area. And because I know that we're working with quadratics, that means that we want the maximum of a quadratic function. So I need to come up with a quadratic function. So the part that I've highlighted, the question, kind of gives me my formula. So I want the maximum of my quadratic, and that quadratic is going to represent area. So I have a rectangle. So there's our rectangle. And we're going to say that the house is on this side. It really doesn't matter where put the house, but let's just say it's on that side. So this is my rectangle, so the rectangle has a length and a width, and because I want the largest area, that means I want to come up with an equation for area that hopefully is going to be a quadratic equation. So I know that the area of a rectangle is length times width. Okay, but that's not a quadratic. So what do? Well, I haven't used other parts of the problem, so this is where let's go back and read the problem. So this is what I mean, and from what I said at the beginning, you have to go back and read the problem to get all the information out of it. Okay, so we get that we have a rectangular garden. Here's our garden. The house is on the side, so we have the house. The side of the house will serve as one side. The garden has 80 feet of fencing. All right, so what does this represent? We haven't used that yet. 80 feet of fence, this is what of the rectangle? We're looking for the area, so it's not the area, and so is around, right? The fencing is what's going to go around, so that's the perimeter. So I know then that the perimeter of this rectangle is 80 feet. My P looks a little weird there. The perimeter is 80 feet. So, but the perimeter of this rectangle, now remember, we're not going to fence this side. We're going to use the house, the wall of the house, as part of our enclosure. But I do have this length, that width, and I also have this side. So we have 3 sides to this rectangle. So that means that the perimeter, or 80 feet, is going to be made up of the L plus W plus L, only 3 sides. We don't need that 4th side because the house is there. So I can say then that 80 is equal to L plus W. And solve for one of them to plug in here and see if we can turn the area into a quadratic function. Because I have a 2 there, I'm going to solve for the W because it's easier. That way I don't have to solve to divide by 2. So I'm going to subtract 2L from both sides. And so we're going to have 80 minus 2L is equal to W. And so now let's go back to our area and see if we can put it in terms of one variable. So I have the length times W. I just got the W, the width based on this picture, and knowing that the perimeter is 80, I was able to solve for the width. So this is 80 minus 2L. So now I've expressed the area in terms of one variable. Now let's hope that this ends up being a quadratic. So let's say as a function of L, right, now that I have one variable, I can say the area as a function of the length of the rectangle is multiply this L in. So it's 80L minus L times minus 2L is minus 2L squared. And yay, there's a quadratic. So we do have a quadratic function. So now we need to find we wanted to find the largest area, so we need to find the maximum. Is this going to give me a maximum? Yes, because that is a negative. The coefficient of the square is a negative. So that means that this is a sad face parabola, right? It's a parabola that opens downward. So it does have a maximum. So how do we find it? Let's complete the square and find the vertex. Because that's not a 1, we need to take it out. So I'm going to take out the minus 2, and I'm left with L squared. And 80 divided by minus 2 is negative 40L. Right? Remember to double check it, multiply it back in, and we should get what you started with. And so now we're going to complete the square. So minus 2L squared minus 40L. And in order to complete the square, we have to have a 1 in front of the L squared. That's why we take out this minus 2. Otherwise, be careful not to just say 80 divided by 2 and square it, because this is not a 1. So once I take it out, notice that 80 became a different number. This is the number now that I need to complete the square with. So what do we add and subtract? To complete the square, we're going to take our negative 40 divided by 2, which is negative 20, and then square it. Negative 20 squared is, what's that, 400? So I'm going to add 400 and subtract 400. That way I haven't changed the problem. And now we complete the square. So I'm going to have A of L is equal to minus 2. This trinomial factors into L, what's that, minus 20 squared. Oops, I should have brackets there. And then minus 400. So my area is minus 2, plug in, or not plug in, distribute the minus 2. So minus 2, L minus 20 squared, and minus 2 times minus 400 is positive 800. And so now I can pinpoint the vertex. So the vertex of this is 2800. Because this is a function of area, that means that this, the y value here, is the area, and it's the maximum. So then we can say that the largest area, what we're looking for, is 800 square feet, and it occurs when the length L is equal to 20 feet. So let's go back to the question. Let's reread it. Remember, I said we have to read this problem a lot. So the question is, what is the largest possible area that can be enclosed? Okay, so we have our answer. The largest area that can be enclosed is 800 square feet. It's important to go back and read the question again, because sometimes it may ask us, what are the dimensions of the rectangle? What are the dimensions of the garden, the largest area? So then it's not asking us to give the area, but the dimensions. So if we were asked for the dimensions, we already know that the length will be 20. We will have to find the width. So the width, you go back and plug it in here. So the width will be what? What did we get? L was 20. So 80 minus 2 times 20. So 80 minus 40, so it will be 40. So the dimensions of this particular garden will be 20 feet by 40 feet wide, and the largest area is 800 square feet. Okay, so always read the problem, and you can go back and reread it as many times as you need to get information from it and identify the keywords. And always focus on the question. What is your task? What are you being asked to find? So let's try another example. So I have this one here. Suppose you have 240 feet of fence to build 3 adjacent rectangular corrals as shown in the figure. So we have a rectangle again, but now we're dividing it up. So maybe we want to keep some type of plant in one versus the other, or maybe cattle, right? Different types of animals in here. What dimensions? So here's our question. What dimensions will maximize the total enclosed area? So in the previous one, the question was, what is the largest area? Notice that now we are looking for the dimensions. So always focus on the question. Okay, now let's go back and read the problem again. Suppose you have 240 feet of fencing, all right, the total enclosed area. So I still want to find the maximum area, and I have a rectangle again. So that means I'm going to have, this is my length, and this is the width. So the area of a rectangle is still length times width. But notice that it is not a quadratic. So we need to turn this into a function of one variable and hope that that function ends up being a quadratic. How do we turn this into a function of one variable? Well, let's go back to read the problem. What haven't we used? Suppose you have 240 feet of fence. Okay, so I haven't used that. So 240 feet of fencing is the perimeter. And so let's see what happens here. So what is my perimeter? What are these 240 feet composed of? So 240 is equal to what? I have the length here and the width. But notice that because we want to build those corrals in there, I have, so this is the length, this is also the length. And because I'm making those barriers, I need material to make those barriers. So these are all W's. So this 240 feet of material needs to make all of this. So it has 2L plus 1, 2, 3, 4W. And now solve for one of them to put in here to turn the area into a function of one variable. So here, which one should we solve for? You can solve for L or you can solve for W. I'm actually going to solve for L because it has the smaller coefficient. So that if I was to solve for W, for example, I'm going to have to divide this 2 by 4, which I'm going to end up with 1/2, which is a fraction. And not that I don't like fractions, but they just don't make things simple. So I'm going to subtract 2L from both sides. Oh wait, I said we were going to do the other one. I'm going to subtract 4W from both sides. And we're going to divide both sides by 2. It's easier to divide everything by 2 than to divide everything by 4. So in this case, I'm choosing to solve for L just because my math will be slightly better. So 240 divided by 2 is 120. 4 divided by 2 is 2. So minus 2W equals L. So now my function is going to be in terms of W. So plug it in here. So A is L, which we just found it to be this. So L is 120 minus 2W times W. So this is my L, is what I found it to be here. So I want to write the equation of the area in terms of one variable so that I can get some information out of it. So we use the perimeter, the information given to us about perimeter, to transform this equation for area in terms of one variable. And now my variable that I have here is W, so I can say that area is a function of W and distribute the W in. So I have 120W minus 2W squared. And I always like to write it in descending order from degree. So I'm going to have minus 2w squared plus 120w. So it is a quadratic, so that's good. So we need to find the vertex. And our question said what dimensions will maximize. So maximize means I want to find the maximum. So this better be a parabola that opens which way? Up or down? If I want a maximum, it better open downwards, which it does. It has a negative, so this is a parabola that opens downward, so it does have a max, so that's a good thing. We're on the right track. So let's find the vertex. So to find the vertex, complete the square. So I'm going to have a w, factor out the minus 2, and I'll have w squared minus 60w. And now we're going to complete the square. So what do I need to add and subtract to complete the square? So what is it that we do? We take the middle coefficient, so minus 60, and divide it by 2. So minus 60 divided by 2 is negative 30, and square it. 30 squared is 900. Negative times a negative is positive, so it's plus 900 minus 900. And the whole point of completing the square is so that when I add that 900, it provides me with the third term of a trinomial that I can factor into a perfect square. Again, hence the name, completing the square. So this will be w minus 30 squared minus 900. And just as we did in the previous one, now distribute that original coefficient we had factored out. So what do we get? So the area function is minus 2 w minus 30 squared. Minus times a minus becomes a plus. 2 times 900 is 1800. So the vertex is 30 and 1800. So that means that the area, that's the maximum area, will be 1800 square feet. Make sure units are right. Feet, yeah, so we square feet, and then we go back and read the question, right? What dimensions? Okay, so in this case, I actually want the length and the width, not the area. I found the area is 1800, that's great, but that's not what the question is asking me to give. So we want to find the dimensions. So I just found that the width, we found the width is 30. How do I know it's the width? Because my function is in terms of the width. So that means that the width is 30 feet. So how do I find the length? The length L is, where did we solve for L? Over here. So notice that we had solved for L here. L is 120 minus 2w, so we can use that. And since the width is 30, we can say L is equal to 120 minus 2 times 30, which is, what's that, 60? 120 minus 60 is also 60. So that means that the dimensions are the length times width. So length times width is a 60 by 30 rectangle. Cool. So always focus on what's the question, what are you being asked to find, and then go from there. So in this case, right, we're trying to find what dimensions will maximize the total area. So I need a formula for area of a rectangle. So here's the area, it's length times width, but this doesn't help me because I have two variables, so I need to put it in terms of one variable. And I don't know how to do that without going back and reading the problem again. Okay, I have fencing, 240 feet of fencing, and I need to use that somehow. 240 feet of fencing is the perimeter of this particular rectangle. Because I have those dividers in there, we are essentially using more material of that length or width. And so that's why we set it up this way. The perimeter, 240, makes up the 2 long sides and those 4 little sides. And then we solve for one or the other. And again, it doesn't matter. I chose to solve for L just so that I wouldn't have to be dividing by 4. So I choose the one with the smallest coefficient, and then we put it back into the one that had 2 variables that I couldn't do anything with. Now I substitute it in there, and now I have a function with just 1 variable, which is a quadratic, which is what we want, and we can go from there. So I hope that that is helpful in solving these types of problems. Email me if you have any questions.